shot put event. Now, the person can throw it with a speed of 13 meters per second, 47 degrees. So what I'm going to do is I'm going to draw an angle, and I'm going to put 47 degrees. I'm going to write 13 meters per second. Whenever you have one of these angle problems, what I really recommend is that you just find Vx and Vy. Vx, Vy, just do it. Oops, I didn't do that very well. Vy. Vx is going to, the x is going to be the cosine one, right? So it's 13 cos 47. I plugged that into my calculator. I got 8.9. And I did 13 sine 47 to get the y. And I get 9.5, which makes sense if you think about it, because it's 47, it's close to 45. These numbers should be pretty close. They are, so we're good. Now the question you want to do is, I would recommend, there's a note, they throw it 1.8 meters above, so right, because the person is tall, so he's throwing it from 1.8 meters, and what it's going to do, right, if you think about it, is it's going to go and it's going to land back at y equal to 0. So I'm going to use my equation, y2 equals y1 plus v1 yt minus 4.9 t squared. That's 1/2 gt squared, and I just sort of do that in my head. Y2 is, this is Y2, this is Y1. Y2 is 0, Y1 is 1.8. The original velocity in the Y, that's this here, so it'll be plus 9.5 t. I want to solve for time, minus 4.9 t squared. Now this is a quadratic formula. I plug it into my lovely calculator solver thing, and I get 2.11 seconds. But of course it's asking how far did our Olympic person throw it. So now we then use the same equation except in the x parameter, and I can say x2, which is what we're solving for, equals x1 plus v1 xt plus 1/2 at squared. But remember, in the x direction, the acceleration is 0. So x2 equals 0 plus v1x, it's 8.9 from up there, times 2.11, and that will give you your answer.